Hey guys, welcome back to geometry. Today we're going to take another look in the practical logic section, but we're going to look more specifically at conditional statements. So these three statements we have down here are examples of conditional statements. Sign up for a 6-month fitness plan and get the first 3 months free. Free phone with 2-year contract. If elected, I will lower your taxes. These are all examples of conditional statements because they can all be written in the form if P, then Q, where P and Q are parts of the whole statement. Okay, so there is a condition, and if that condition is satisfied, something else will happen. So let's take a second and rewrite each of these in if-then form. So the first one says, sign up for a 6-month fitness plan and get the first 3 months free. The condition that needs to be satisfied is if you sign up for a 6-month fitness plan, then, well, what happens if you sign up? Then you get the first 3 months free. 3 months free. Okay, the next one. What condition needs to be satisfied? Well, if you sign the contract, okay, so that's the condition that needs to be satisfied, then you get a free phone. And if elected, I will lower your taxes. Well, this one's pretty much already there. If I am elected, then I will lower your taxes. Okay, so now each of these statements is written, if one thing happens, then another thing will happen. That's basically the format for a conditional statement. Okay, now, in each of these conditional statements, I've been saying there is a condition that has to be satisfied and something else that will happen. We have some special words for those. Okay, the part that immediately follows the word if is called a hypothesis. That's the thing that needs to be satisfied. Then we have what follows the then word, and that's the conclusion. So the hypothesis is the condition that has to be satisfied. The conclusion is what happens if that hypothesis is satisfied. And we have a shorthand symbol that we use for this because math is all about shorthand. Instead of writing it all out, we can just write P arrow Q. Okay, now we don't read this P arrow Q. The way that we would read it outside is if P, then Q, or P implies Q. And either one of those can be how we read this statement. And rewrite the statements above as if-then statements. Well, we took care of that already. Okay, so now what I want to do is look at each of these statements here, identify the hypothesis and the conclusion of these statements. So I have if A, B, and C lie on line L, then they are collinear. So the hypothesis, we said, is this part that follows immediately after the word if. And what follows immediately if is A, B, and C lie on line L. Okay, and there is our hypothesis. The conclusion is what we can say based on that hypothesis. And what we can say here is that they are collinear. Okay, and that's really the definition of collinear, points that lie on the same line. Okay, and let's get this squared up. There we go. Okay, part B, another example. The Spartans will advance to the next round in the playoffs if they win on Tuesday. Well, they did win on Tuesday, so they are going to the next round of the playoffs. Good job, guys. So let's talk about the hypothesis and the conclusion. Okay, the hypothesis is what needs to happen first. Now this one, it's flipped around. Okay, this one they write the conclusion first, and then the hypothesis comes at the end. So what's important is that what follows the word if is the hypothesis. So the hypothesis is the Spartans win on Tuesday. The conclusion is what happens because of that. Well, what happens because of that is they advance to the next round of playoffs. Okay, okay, so hypothesis is what follows the word if. Conclusion is what happens if the hypothesis is satisfied. Okay, now identify the hypothesis conclusion of each statement and then write the statement in if-then form. So we want to take whatever the statement's given to us as and rewrite it as if P, then Q. So the hypothesis here. We have an angle with a measure greater than 90 degrees is an obtuse angle. So the condition that needs to be satisfied is an angle has a measure greater than 90 degrees. Okay, so we have greater than 90 degrees. Hold on a second here. We got a little glitch. There we go. An angle has a measure greater than 90 degrees. Okay, that's the hypothesis. The conclusion is what happens because of that. Well, if the measure is greater than 90 degrees, the conclusion is it is an obtuse angle. So now we want to write it in if-then form. So we would say if an angle has a measure greater than 90 degrees, then it is an obtuse angle. Okay, and we know the other part of that is it has to be greater than 90 degrees, but also less than 180 degrees. But for the purpose of this exercise, we can just say greater than 90 degrees. Okay, next up, okay, we have perpendicular lines intersect. Okay, well, this one's a much shorter statement, so we have to think a little bit more. What is the condition that's being satisfied? It's the hypothesis. Well, what has to happen first is that the lines are perpendicular. So we can say if lines are perpendicular, okay, that's the hypothesis, then the conclusion is what happens because of that. The conclusion is they intersect. Okay, so our if-then statement, if two lines are perpendicular, then they intersect. Okay, and we could say, well, why not the other way around? Why not that the hypothesis is that the lines intersect and the conclusion is that they're perpendicular? Well, the simple answer for that is not every pair of lines that intersect is perpendicular, but every pair of lines that are perpendicular have to intersect. So that's a little bit of trick you can use to figure out which one's the hypothesis and conclusion when it's a very short statement like this one here. Okay, let's flip over to the back, take a look. Okay, there are truth values for conditionals. Okay, consider the following possibilities for the given statement. A Little League coach says to his team, if we win, I will buy you ice cream. Now, we're going to look at truth tables here, and we're going to try to determine what the truth table looks like for an if P, then Q statement. So first off, let's take a look at what P and Q are. Okay, P is the hypothesis, and the hypothesis for this statement, okay, if we win, then I will buy you ice cream. So P is we win. Q is the coach buys ice cream. Okay, now what we want to look at is to fill this truth table out, we want to determine whether or not the coach lied to his players. Okay, so let's set up the truth table. We have the team wins and the coach buys ice cream. So the team wins, P is true. Coach buys ice cream, Q is true. So both of these are true. Okay, well, did the coach lie to his players? They won. He bought ice cream. No, he told the truth. Okay, next up. The team wins and the coach does not buy ice cream. Well, the team won. That's T. Okay, or excuse me, that's P. So yes, they won. And the coach did not buy ice cream. Okay, so Q is false. So he told them if they win, he'd buy them ice cream. They won, and he didn't buy them ice cream. Okay, that's a false statement. He lied to them. Next up, the team ties, and the coach buys ice cream. Well, the P had to be that the team won, and they didn't win, so that part is false. And the coach buys them ice cream, and that's Q, and we have that as true. Okay, now, did the coach lie to his players? He said, if we win, I'll buy ice cream. They didn't win, but he still bought ice cream. He didn't lie to them. Okay, he didn't say anything about a tie. So that statement is still true. Okay, and then finally we have here the team loses, and the coach does not buy ice cream. So part P, okay, we win. Here we have the team loses, so that's false. And then the coach buys ice cream. That part of the statement is true. And we want to ask ourselves, did the coach lie to his players? Okay, if we win, I will buy ice cream. The team loses, and he still buys ice cream. Well, no, he didn't lie to them here. He didn't say anything about what happens if they lose. So whatever happens if they lose, he couldn't have lied to them because he didn't mention it. So what we can see with these conditional statements, what's always going to happen with these, first off, conditional statements are anything of the form if this, then that, if P, then Q. The shorthand notation is P arrow Q, which we read if P, then Q, or P implies Q. The first half of the if-then statement is called the hypothesis, and the second half of the if-then statement is called the conclusion. Now, from this truth table up above, we can see that the conditional statement is only false if the hypothesis is true and the conclusion is false. Okay, so this is the only time where this if-then statement was false. The hypothesis was true, the conclusion was false. Everything else, that if-then statement, that conditional, ended up being true. Okay, so the only way that an if-then statement can be false is if the hypothesis is true and the conclusion is false. Otherwise, it's always going to be true.